In this section, we're going to be solving equations that involve decimals. There's no real new material I have to do. I just have to show you that solving the equations uses the exact same methods that we've already done. So let me just grab some examples to tell you what I'm talking about. So all of these that we're going to be doing are solving equations. So when I say solve r plus 0.9 equals negative 0.3, then the idea is to get r by itself. Well, these type of equations are our easiest ones. In order to get r by itself, I want to subtract 0.9. But remember, whatever you do to one side, you have to do to the other side. I think it's called the law of equality. So we get r by itself after doing that. Well, what does the other side turn out to be? Well, the other side is you're going to be adding two negative numbers together. Since they're both negative, their sum will be negative. And then what do you got to do? Add them like regular positive decimals. Since they were both negative, you add them together. I get 2 with 1 carry over, I get 1.2. And that takes care of that equation. So I'm just going to run through tons and tons of equations. Here we have p minus 5.1. That equals 1.8. So just like the last one, I want to get p by itself. So there's a minus 5.1 on that side. To undo that minus, I'm going to add 5.1 to each side. And so we'll get p by itself like we should. There's over here, I don't need to go off to the side for this one. These are just two positive numbers. Add them column by column. The 8 and the 1 gives you a 9, and the 1 and the 5 gives you a 6. So p equals 6.9. This time we have 0.43 equals v plus 0.61. Now remember, another thing about these equations is it does not matter which side the letter ends up being on, as long as it's by itself. So seemingly attached to the v is this plus 0.61. So I'm going to subtract 0.61 from each side. And that will get v by itself. Another thing I want you to do while you're solving your equations is to keep your equal signs lined up. That way you'll have a clear definition of left side versus right side. Now the other side, I have a positive. So the other side is what I essentially have 0.43 plus a negative 0.61. So positive plus a negative. In this case, the negative is, I don't know how to say it, more dominant, more powerful than the positive, because it's more negative than the other one is positive. So I know it's going to be negative. Now, whenever you add opposite signs, it's always a subtraction problem. Always the bigger of the two minus the smaller of the two. I've already got the sign accounted for in the problem itself. So let me go ahead and do my subtraction. I'll take 1 away from the 6 to give me an 11. Minus 3 will be 8. 5 minus 4 will be 1. And it looks like 0.18 is my answer. That takes care of the ones involving addition or subtraction. Now another type that you had involved multiplication. Something like this. Solve 3p equals 2.1. So to do this kind of a problem, now I'm multiplying the letter p by the number 3. To undo multiplication, I'll use division. And now all I have to do is 3 into 2.1. So let's see how it works. 3 doesn't go into 2. Let me keep bringing in the decimal. But 3 does go into 21 exactly 7 times. Since the remainder is 0, I know that my answer is 0.7. Next one, I have negative 8t equals negative 9.6. Now, a lot of students think because they see the negative in front of the 8, they think about adding, but that's not true. Let me put a dot after the 8 and before the t. That way it reminds me that it's a multiplication problem there, and to undo that, I'm going to use division. So I do get t by itself. The negatives cancel out, so my answer will be positive. I just have to do 8 into 9.6. So 8 goes into 9 one time. Bring down the 6, and 8 goes into 16 exactly twice. So the remainder is 0, and I know that my answer is 1.2. Similar problem. It's actually the same problem. I'm just going to put the letter on the opposite side. We have negative 72 equals 0.9w. So now I hope it's clear that you'll want to divide by 0.9 on both sides. That'll get w by itself. The other side, you have a negative number divided by positive, so I immediately know my answer is negative, and I'll just wait to see what happens to the decimals. I have to do 0.9 into 72. And remember, we don't do division, long division at least, where the decimal is on the outside. So I need this decimal to move one place. That means on the inside of here, I need the decimal to move as well. So this problem, and I've warned you, don't try to do the division with these little things in there, the things that remind you to move the decimals. Rewrite it so that you can do it correctly. So the outside becomes a 9, and the inside becomes 720. So 9 goes into 72 8 times. Now, when you bring down the 0 like this, because 72 minus 72 is 0, 9 goes into 0 0 times. So your answer here is negative 80. I didn't go to decimals because my remainder zeroed out before I got there. Now, all of the problems that we've done so far were, I guess you'd call them one step. I mean, really, 2 steps, I guess, if you think about it. I did division, but then I had to do the long division off to the side. But to get w by itself took exactly 1 step. The next problems that we're going to be doing will involve multiple steps, like this one. So here I have 0.5f minus 4.3 equals negative 0.8. So I want you to think about this for a second. Let me go off to the side. If I were to give you a problem like this, say you knew what the f was. I'm not saying it's 7. I'm just saying suppose you knew what number this was here. You would multiply and then subtract. Now remember, when you're solving an equation, you want to undo. So what we did is we multiplied first and then subtracted. We want to undo it in the reverse order because that's what undoing means. So I will first, to undo, first add, and then divide. So that's what I'm going to do here. I'm going to undo the order of operations so that I can come back and find my way to f. So the first thing I'll do is I'll add 4.3 to both sides. To do that addition, they have opposite signs. That means you're ultimately going to be doing a subtraction. You're going to be taking the bigger number, the 4.3, and minus the smaller number, the 0.8. Since the bigger number is the positive one, my answer will be positive. I'll do no sign. But let me give myself some space to work here. I need to do 4.3 minus 0.8. And so to do that, I'll have to bring over a 1. Borrow, I guess is the right word. 13 minus 8 is 5. Bring down the decimal. Then 3 minus 0 is 3. So I get 3.5. Now to finish this off, I'm going to divide by 0.5 on both sides of the equation. So that's where I'll do 0.5 into 3.5. However, I'm going to do like I did in the last problem, and I'm going to move the decimal over one place on the outside and the inside. So I'm really going to do 5 into 35. And that's really easy because this is a problem that you knew from the multiplication tables. Everybody knows that 5 times 7 equals 35, and the remainder is 0. So my f in this problem equals exactly 7. For my next example, we'll have to solve, I think I'm going to put the letter on the opposite side. 1.3 equals 0.4m plus 0.5. Just like the last time, I've got 2 steps that I have to undo. The first thing I'm going to do is undo the addition by subtracting 0.5 from both sides. Now, I don't need to go off to the side to do this one. The numbers are lined up right there. I know that I'm taking a positive minus another positive. Since 1.3 is the bigger number, my answer will be positive. To do this, what I'll need to do is borrow from the 1, and I'll get 0.8 equals 0.4m. Divide by 0.4 both sides. So you would normally do 0.4 into 0.8, but I need the decimal to move one place so that the outside does not have a decimal. So I'll have 4 going into 8, and it doesn't take rocket science to see that that goes in there exactly twice. And so the right-hand side equals a 2. I'm sorry, the left-hand side equals a 2, and the right-hand side is where my m was waiting. Now we move on to the toughest of these type of problems. This involves several steps, not just 2. And it looks like this. I have 7.9y minus 58.2 equals 6.3y plus 13.8. The way I typically work these is I try to decide on what side I want the letter to appear on. So either I'm going to subtract 7.9y or I'm going to subtract 6.3y. I choose to subtract 6.3y because it will not introduce a negative number in front of the y. And I can do this subtraction directly here. I'm going to get 1.6y minus 58.2 equals 13.8. And you can see that now it's exactly like the problems that we were just doing. Now it's a two-step problem. The first thing I'll do is add 58.2 to both sides. And I'll get 1.6y equals, this one again I can do column by column right there. The way I set it up was nice. The 8 plus 2 will give me a 0. And then I'll put a 1 up here for carryover, put my decimal. 1 plus 3 is 4, plus 8 is 12. I have to carry over again, and then 7. So I get 1.6 equals 72.0. And so I will divide 1.6 into both sides of the equation. This tells me I got to do 1.6 into 72.0. However, like all the rest of these so far, move over 1, move over 1. I don't know if I need to put an arrow there or not, if that's helpful, or I don't know. I see these on students' papers all the time, so I'm not sure what they're using there. So I'll put a 16 on the outside and 720 on the inside. Now let's see how this works. 16 goes into 72 how many times? I'm guessing 4 times. 4, 64. And then 72 minus 64 is 8. Bring down the 0. 16 goes into 80 exactly 5 times with the remainder of 0. So this tells me that y equals 45. Here we have a further complication. 4 times z plus 3.8 equals 3z plus 2.1. All right, on these, probably the first thing I tell students in any problem involving equations and solving them is to simplify each side of the equation first. So if you look on the left side, that means that I should use the distributive property to break out of these parentheses. So let me do that. I have 4z plus 4 times 3.8, and I'll do that off to the side. So 4 times the 8 is 32, put a 3. 4 times 3 is 12, plus 3 more is 15. And I have a total of 1 decimal in the problem, so that makes this 15.2. And here, same thing as before, I'd like to get the z's to occur on just one side of the equation. So I'm going to subtract the smaller one. I'm going to subtract 3z to avoid a negative sign attached to the z. This leaves me with z plus 15.2 equals 2.1. Now notice, once I subtract 15.2, I'll have my answer because there's nothing in front of the z that I'll have to divide by. Z will already be by itself. So let me subtract 15.2 from each side. And let's see what we get. Z equals. Now you have a positive number minus a bigger positive number. That's definitely going to be negative. And the easiest way to do this is to do the 15.2 minus 2.1, bigger minus smaller. And it looks like I get 13.1. I already had my negative waiting around for me. And for my last one, I have 0.2 times 3h plus 4 equals h minus 5. So as before, the first thing I'm going to do is simplify. In this case, the left side, it's the only one that needs simplified. So let's go ahead and do those. I don't think it's going to stretch your imagination if I say 0.2 times 3 is 0.6, then with the h, plus 2 times 4 is 8, but move the decimal over 1 and you get 0.8 equals h minus 5. Now this time, I would prefer to subtract 0.6h from each side, because it will prevent a negative number in front of the h. Over here on the right hand side, I have 1h minus 0.6. So I'm going to go 1.0 minus 0.6. Borrow. And I end up with 0.4h minus 5. Let me add 5 to both sides. So I get 5.8 equals 0.4h. So what am I going to do next? I'm going to divide by 0.4. So we're going to have 0.4 into 5.8. Move the decimal 1, move the decimal 1. 4 now will go into 58. Let's see how many times. 4 goes into 5 one time. Bring down the 8. 4 goes into 18 4 times. Now, if I wasn't interested in a decimal, I would be done right now. I would have a remainder of 2 and write my answer sort of that way. But I don't. I want to go and make it a decimal. So after the 58, I'll put the decimal in, and I'll put the decimal in after the 14. Let me put a 0 after the decimal so that I can bring it down. 4 goes into 20 exactly 5 times. And we have a remainder of 0. So that gives me then, on the right I had my h, and on the left we're going to get 14.5. So those are the techniques for solving equations that you'll be needing for section 5.8. Let me now move on to section 5.10. Some more geometry stuff. We have circles. We've got spheres. We've got cylinders. And we have cones. So those are the geometric figures we're going to be working on. Remember, the formulas that we're going to be using here to find volumes and areas, circumferences, and all that stuff are not, they won't have to be memorized by you. They'll be given to you on an exam. So let's go ahead and start everything off with circles. Now, what I've done before I came up with this stuff is I tried to find myself good pictures to use, and this first one looks really, really nice. So all I'm going to do is copy it out of here, and then I'll use it in my discussion. So there we go. Probably the things that you know about a circle are, if I go 1/2 from the center to an edge, that's the radius. So the r equals the radius. And if I go all the way across, that's the diameter. So I don't want to write it at the same time. Maybe let me go ahead and do this. So to go all the way across, then I'm trying to. I do want to keep I want to try to keep everything straight. So what we're going to do then is I don't think I have a straight line for this. I probably do. Let's try this one here. Of course, didn't make it long enough for me. Okay, I can live with that. This would be the diameter, which goes all the way across. So d equals the diameter. There are two things that we want to know that we usually try to figure out with a circle. And that's how far is it around, that's the circumference, and what's the area of it. So let's take a look at some of the formulas for this. For the circumference, or if you want to think of it this way, the perimeter, that's the length around the outside of the circle. The circumference is given by c equals 2 pi times r, or the same thing is pi times the diameter. So 2 pi times the radius, and it's the same as pi times the diameter. It just depends on the problem that you're given. This line here is bothering me a little bit. It doesn't seem like it's in the right spot. I'm going to see if I can sort of make it go into the right spot. Not really. I wanted to move it down a little bit, but it does not look like it wants to move down with me. So I guess, well, I'll quit playing around with it. Or I won't. Leave it at that. All right, then the area is given by pi times the radius squared. So we're going to do a couple of examples illustrating these formulas. So let's start with an example. What I'm going to do is find a few items exactly and approximately. You'll see what I mean in a minute. Find the diameter, circumference, and area. So let me go ahead. I wonder if I still have a circle saved. We'll find out. I'll do Control V, and it still is there. So what we've been given here is a radius of 4 miles. So the diameter, I don't think I wrote it up here, did I? No, I didn't, but it seems pretty clear to me that the diameter being all the way across and the radius only being half across is, you ought to know that diameter is twice the radius. So with that in mind then, my diameter is 2 times the radius, which is 4, and that'll give me 8. And then to finish off the problem, put in your units. So this will be miles. I find them cumbersome to use while I'm doing the problem. Very easy to just tack them on at the end. And then what else do we need? The circumference, c equals 2 pi r, and that'll equal 2 pi times the radius was 4. Now if I multiply 2 and 4 together, I'll get 8 pi, and this will be miles. Remember, the circumference measures the distance around, so it's not an area, it's actually a length. So the answer that I have here, 8 pi miles, is exact. You may be asked for an exact answer or an approximation. If I want to approximate it then, I will do 8 times, for pi, your book wants us to use 3.5 5.14. So this is the approximate value then. I will do, I guess over here somewhere, 8 times 314. And I'll remember to move my decimals 2 places when I'm done. So 8 times 4 is 32. Carry over the 3. 8 times 1 is 8, plus 3 more is 11. Carry over the 1. 8 times 3 is 24. 25. So this is 25.12. Remember, I had 2 decimals. That's why I moved my decimal 2 places. 1, 2 is where the decimal should have been. And then put in the units. MI. And for the area, that's pi r squared. So this is pi times, the radius was 4. If you do 4 squared, that is 16. So you get 16 pi. Now this is where you got to be careful with your units. Area is measured in units squared. So what I need to attach here is miles squared at the end of that. And that, of course, is my exact answer. If I want an approximation, so I'll do my squiggle lines for an approximation, I'll do 16 times 3.14. Now, sometimes I have my decimal and sometimes I don't. I'll figure out the decimals when the problem is done anyways. So this is 16 times 3.14. And you ignore the decimal as you're doing this. So 6 times 4 is 24. Carry the 2. 6 times 1 is 6 plus 2 is 8. And then 6 times 3 is 18. And then 1 is always easy. I can just write 314. And then start adding these column by column. 8 times 4 is 12. Carry the 1. 10. Carry the 1. 5. It looks like I end up with 50.24. Don't forget to move the decimal 2 places for the because you had 2 decimal places involved. This is an approximation. Same problem. Find the diameter, circumference, and area. This time, my radius is 3/4 inch. So start with the diameter. D equals 2 pi. 2 times the radius. That's 2 times 3/4. Cancel a 2. And we end up with 3/2. Since it's a diameter, it's a length. So I'll put inches. Circumference equals 2 pi r, which is 2 pi times 3/4. Same exact thing as before. We end up with 3/2 pi. And since circumference, I'll put in inches. Now, whenever your answer is like that, that's exact. If I want an approximate version of that, I'll do 3/2 times 3.14. My guess is it would be best to change everything to decimals than to change everything to fractions. So the 3/2 is easy enough to change to a decimal. You do long division, but you can check on what I'm doing. 3/2 is 1.5. and you're multiplying that by 3.14. So let me go ahead and do that. I'm going to do 314 times 15. And then I'll put in 3 decimal places at the end of the problem. So we'll start. 5 times 4 is 20. Carry the 2. 5 times 1 is 5, plus 2 is a 7. 5 times 3 is 15. 0. And then, oh, that's nice. You got a 1. 3, 1, 4. Carry the 1. 6, 7. 4. So I had a total of 1, 2, 3 decimals. So I get 4.710 inches. That's an approximation. And you know that 0 at the end is not crucial. I can drop it and just have 4.71 inches. So this is my side work. Let me keep it that way. For the area, that's pi r squared. And we had 3/4 inch for the radius. And when you square a fraction, you're going to get 9 over 16. 3 squared is 9. 4 squared is 16 times pi. And since we're doing area, this is units cubed. You'll put inches, units squared. You'll put inches squared at the end. So this version of the answer is exact. However, if I want to approximate, what do we do? Now I have to do 9/16 times 3.14. This seems very undesirable. First, I have to do the 9 over 16. Let me make that look more like a 16. So to do that, I have to do 16 into 9. It doesn't go, so I'm going to have to go decimals on it. Well, I figured that anyways. Let me go 9.0. 16 goes into 9.0 5 times. Bring down another 0. 16 goes into 100. Let's see, 6 times. I think 6 times, yes. 96. 4. And then I already brought down a 0. I need to add another 0 and bring it down. 16 goes into 40 twice. I need to add one more 0 and bring it down. 16 goes into 85 times. So I have to do 0.5625 times 3.14. This is a lot of work. So, well, if I only want, all I care about is getting this to the nearest 100th, because 3.14, we only did that to 2 decimal places. So what I'm going to do is 0.56 times 3.14. So everything is rounded to the nearest 100th place. So I'll do 314 times 56, and when I'm done, I have 1, 2, 3, 4 decimal places that I have to account for. 6 times 4 is 24, carry the 2. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. 5 times 4 is 20, carry the 2. Oh, the 2 is already there, very nice. 5 times 1 is 5, plus 2 is 7. And 5 times 3 is 15. So let me add all my numbers together. 5, carry the 1, 7, 1. And then I had 1, 2, 3, 4 decimals. So 1, 2, 3, 4. Looks like 1.754, 1.7. Yeah, I'm trying to think. 1.7584 And so where did the thing go anyways? Oh, it's way up there. My approximate sign was way up there. I'm 1.7584. And this will be inches squared. That'll be an approximation, of course. So while you're doing that, I don't know if we should put the final answer into 2 decimal places. It probably would not hurt. Let's go ahead and do that. So it'll be sort of an exercise in rounding, and we'll see what happens. Oh, something tells me I made a mistake somewhere. Hold on a second. Go down here. Let me look again at this. 6 times 4 was 24. Then 6 times 1 is 6 plus 2 is 8. Good. 6 times 3 is 18, which that's all right, but something seems wrong about these numbers. 5 times 4 is 20. I carried the 2. 5 times 1 plus 2 is 5 plus 2 is 7, so that's right. And then 3 plus 5 is 15. Nope, those decimals were right. All right, so come down. I'm going to round to the nearest hundredths place. So that 5 is the digit I'm talking about, and that 8 says round up. So it looks like 1.76 inches squared. That's my approximation. That was a long problem, very long. Let's move on to the next type of a figure. So anytime you get the decimal version with these things, whenever pi is involved, you can never write all the decimals because pi goes on forever. So you're going to have to approximate those. And I think to the nearest hundredth is usually what's asked. All right, our next thing that I want is a sphere. Let me go ahead and grab one of those. Notice to draw one of these things, it's no different than drawing a circle, but then inside of it, adding this little half circle and these dots here, give it a three-dimensional view. So now we're going to take a look at spheres. There's 2 things that we're going to be doing with them. One is we'll be doing the volume, and V will equal 4/3 pi times r to the 3rd power. The radius, of course, is the same as before. It's the radius, it's the distance from the center to the edge of the sphere. Let me make that dot better. And we'll also be looking for something called the surface area. We'll call it SA, and that equals 4 pi r squared. That's the area. If you were to paint the outside of this thing, or if you were to try to carpet it somehow, this is how much carpeting you would need to cover it with. So let's do an example to illustrate this problem here. We'll do like I did before. I'll give exact answers and I'll give approximate answers. So compute the volume and surface area. And let me see if I still have a picture saved so that I can just Control V it there. There it is. And this one your book drew from the center. I don't know why they did it here. We have 8 centimeters. So the radius is 8 centimeters. In case you can't see what I wrote. All right, so let's see what we have then. The volume will equal 4/3 pi times 8 cubed. 8 cubed is 512. So 4/3 pi times 512. Well, when I multiply it to the 4/3, so if you think of it as 512 over 1, I can take 512 and multiply it by 4. So I think I get 2048. So what I end up with is 2048 over 3 times pi. And since it's volume, that's units cubed. So I'm going to put cm to the third after that. And that is exact. Now for the approximation, we can do, first let me do this part of it, and then I'll change pi to 3.14. So I'm going to do 2048, 3 goes into that, and I'll get that to 2 decimal places. So 3 goes into 20 6 times. 20 minus 18 is 2, bring down the 4. Bring down the 8, 3 goes into 8 twice, and this is where I'm going to start having to go into decimals. So bring down a 0, 3 goes into 20 6 times. And there it is again. So what's going to happen is the 6's go on forever. So 682.6 with a bar over it. Now I want 2 decimal places. The 6 with a bar will be very difficult to multiply with. So to 2 decimal places, I have 682.67. That's because if you do 682.666, suppose you stop at the third 6. Looking at the second 6, the one after it tells you to round up. So my approximation will be 682.67 times 3.14. This is not going to be pleasant, but let me go ahead and do it anyways. Try to give myself some space. I'm going to do 68268 times 314. Let's see, 4 times 8 is 32. Carry the 3. 4 times 6 is 24 plus 3 is 27. Carry the 2. 4 times 2 is 8. 10. Carry the 1. 4 times 8 is 32 plus the 1 is 33. Carry the 3. 4 times 6 is 24 plus 3 is 27. Then I'm going to put a 0 for the next row. Well, it has a 1 in it, so this is really easy. All I got to do is copy down the digits and not make a mistake while I'm copying them down. And then for the last row, we put 2 zeros first. And I start doing 3 times all these things. So 3 times 8 is 24. Carry the 2. 3 times 6 is 18 plus 2 is 20. Carry the 2 again. 3 times 2 is 6 plus 2 is 8. Don't have to carry anything. 3 times 8 is 24. Carry the 2. And then 3 times 6 is 18 plus 2 is 20. So let me go ahead and then add up all of these columns. You should try it yourself to make sure you're getting the same answers I am. 4 plus 2 will be 6. I'm not going to be very vocal while I'm doing this. Right now I'm on this column. 7 plus 8 plus 8 is 23. Carry the 2. 4, 6, it's 10, 14. Carry the 1, and then 2. And then we had 1, 2, 3, 4 decimals. So starting back here, I'll go 1, 2, 3, 4. So I get approximately 2143. I'm going to round to 2 decimal places. So for this, I'm going to get 0.21. 0.62 because that 5 will tell me to round up. So 0.62, and we want centimeters. This time we want cubed because I was still working on the volume. So it depends on how much you're asked for, how many decimal places that you're asked for will determine on how much of this you want to do. But for the most part, I think 2 decimal places is going to be enough because they usually give you pi to 2 decimal places. So that usually means that the accuracy expected in the whole problem is 2 decimal places. Oh, wait a minute. Can't leave just yet. We did the volume. I have not done the surface area yet. So the surface area, SA, is 4 pi r squared. And so, where was the radius again? The radius was 8 centimeters. So we'll have times 8 squared. 8 squared is 64. So we get 4 pi times 64. 4 times 64 is 256. And since we're dealing with area, that's units squared, I think we were in centimeters. We are in centimeters, so I'm going to do cm squared. That version of the answer is exact. Now, if I want an approximation to it, I'll do 256 times 314, and then I'll move the decimal 2 places when I'm done with this, because 3.14 had 2 decimals. So let's go ahead and do this multiplication. 4 times 6 is 24, carry the 2. 4 times 5 is 20, 22, carry the 2. 4 times 2 is 8, plus 2 is 10. And then I can just write, and once again I'm getting ahead of myself because that line shouldn't be there yet. I have two more rows. Whenever you multiply by 1, that's sort of nice because I just have to write the digits. And then a 3, I'll have 3 times 6 is 18, so I'll 8, carry the 1. 3 times 5 is 15 plus 1 is 16, carry the 1. 3 times 2 is 6 plus 1 is 7. And now let me add up my columns. So I have 79,384. And remember, pi had 2 decimals lurking in it, so I'm going to move the decimal place back. So I get 793.84 centimeters squared. And that's an approximation. So let me check that out to make sure. 256 times 314. I want to look at the intricacies of the multiplication. I want to see if I messed up any of the digits. And so I think I did somewhere now that I think about it. Right around here it looks like there is a mistake. I have, I don't think I caught that 1 there. You see it, the 1 in the 1024. 1 plus 1 is 2, plus 2 is 4, plus 6. So right there, I had a 10 and I needed to carry. So I have 803.84 centimeters cubed. Now, the next shape that we're going to move on to is cylinder. Let me go ahead and grab a picture of one of these things so that you know what you're dealing with. Cone, cylinder, there we are. Got it, that's a good looking picture. I'll use that one. paste it in here. Very big. All right, here's what you're doing. I could probably make it smaller. I think I will do that because I don't want it taking up so much of the page. And I think that's pretty good. There's two quantities we're going to be interested in here. You'll notice that the top is a circle. And so it has a radius like anything else. But it also has a height, which goes from the edge of the top to the edge of the bottom. There's two formulas we're going to be interested in. The volume, and the volume will be pi r squared times h. And the surface area. Surface area is much worse. We're going to have 2 pi rh plus 2 pi r squared. So I'm not going to explain the intricacies of this. It's just a matter of plugging the numbers into the right spots. So let's go ahead and do an example to illustrate these formulas. So compute the volume and surface area. And let me have my, well actually I'll tell you what, I'm going to copy this one since it's a little easier, and we'll just throw it in here. So what I'm given here is I have a radius of 6 feet. They decided to put it over here 6 feet, and I have a height of 20 feet. All right, so the volume is pi r squared h. That'll be pi times r is 6, so I'll square that, and then h is 20. Well, 6 squared is 36, so I get pi times 36 times 20, which ends up being 720 pi. Now, since it's a volume, make sure you put a units cubed. So then I'll have ft to the third power. That version of my answer is the exact one. Now, if I want an approximation to it, I'll have to do 720 times 3.14. So let me go ahead and do that one. I guess I'll do it over here. 314 times 720. I'm putting the 720 on the bottom simply because the first row will just be 0 and I won't have to worry about it. So I'm actually starting the second row here. Or you could do something like that. 2 times 4 will be 8. 2 times 1 will be 2. 2 times 3 will be 6. And then for my third row, 7 times 4 is 28. I'll put a 2 up here. 7 times 1 is 7 plus 2 is 9. 7 times 3 is 21. So we add this all up, I'll get a 0, an 8, a 0, carry the 1, 16, carry the 1, 2, 2. And the 3.14 had 2 decimal places, so I'll move 2 decimal places back, like so. And my answer then that I will use will be 2260.8. You can put a 0.80 if you want, but there's no need to have the 0 in there. So let me just put my feet cubed, and that's the approximation. So far we have done the volume. Now the surface area was 2 pi rh plus 2 pi r squared. So let's punch these numbers in. I have 2 pi, the radius was 6, and the h was 20. Once again, r was 6. So let me multiply all these numbers out here. 2 times 6 is 12. 12 times 2 is 24, but add a 0 and you get 240. So 240 pi plus, for the other one, I get 36 times 2 is 72. For a total of 312 pi. And remember now, we need to put the units squared, so feet squared. That there is the exact answer. To get the approximation, I need to do 312 times 3.14. So this way I don't see any benefit to having one to the other on top of each other. So I'll put 312, 314, and remember to move the decimal 2 places to the left. So starting with the 4, 4 times 2 is 8, 4 times 1 is 4, 4 times 3 is 12, 0. Oh, this is times 1, so I have 2, 1, 3, that's easy enough. And then finally 2 zeros. 3 times 2 is 6, 3 times 1 is 3, 3 times 3 is 9. And let me add my columns up. I got a 9 there, I get 6, 7, and then I bring down the 9. So then I move my decimal to the 2 places back. So it looks like this is going to be 979.88, and we need feet squared. And of course that's the approximation. And once again, every time I multiply these things, let me be careful. This happens to students all the time. I just noticed this. See this? Let me get my mouse here. See this 4 and see this 2? When you add them together, you don't get 8. You can probably guess what I did, because my students do it all the time as well. They multiply instead of add it. That there should be a 6. So let me fix this here to make it into a 6. So this was the surface area. And so we handled that problem. We have one last type of figure that we're going to be looking at, and those are the cones. And we'll only do one formula because anything else with these is a little too brutal for this course, we believe. So let me grab a picture of a cone. I think I have one in here. Here we are. And there's one right there. I think I'll use that. Actually, I like the one next to it a little better. I think I'll use that one. Okay, for this one, we have 2 quantities we'll be interested in. As usual, the radius of this bottom circle will be crucial, but also the height will be crucial as well. Let me see if I can get my height to come out right. It does not want to. It's being cruel to me. Let's see if I can start at the very top and draw something that's reasonably straight downward. There we go. And then they usually put a little box down here to indicate that it's a right triangle. I mean a right angle. And then the h is the height of the thing. So the only thing we're going to be doing with these is the volume. That's 1/3 pi r cubed. So as an example, find the volume. And the cone that we have, let me go ahead and paste it again. Our cone has a height of 6 feet. And a radius of 3 feet. So the volume will equal 1/3. I suddenly realized I made a mistake on this. 1/3 pi r squared times h. That's the actual formula for the volume. So let me write it down here. And let me throw in my numbers. I get 1/3 pi. R was 3, so I'll 3 squared, and H was 6. And let me go ahead and multiply this all out. I get 1/3 pi times 9 times 6. You'll notice one thing that's nice here is that the 3 down here cancels with the 9, and we end up with 18 pi. And since it's a volume, I need to put ft to the 3rd power. So that's an exact answer right there. And then for an approximation, we'll do 18 times 3.14. And usually now, when you do a multiplication like this, I do find it easier to put the smaller number below, because you'll have less rows that you have to add up. Now the 8 times 4 is 32. Carry the 3. 8 times 1 is 8, plus 3 is 11. Carry the 1. 8 times 3 is 24, then plus 1 is 25. Now, oh good, the 3, 1, 4, all I do to do is copy those down. And now let me get my numbers added up. 5652. And because pi, the approximation we're using, has 2 decimals, I'm going to move this decimal back 2 places, and I'll get 56.52 cubic feet. And that is the approximation.